Thank you so much for the introduction. It's a real pleasure and honor to be able to come and share my thoughts on future of SDN. So, and my team as always gave a great talk, and I wish we could continue the conversation with my team, but I guess we don't have a choice, so I will continue with my talk. So, today I want to make a case to you that we can accelerate SDN adoption with an open source SDN control plane. And so, that is the case I want to make to you, but with a difference. So, the idea is not just to build an artifact that is open source, because that we have done before, but what is important is to build this particular open source SDN control plane with how our industry works and how we can bring about a change in the industry with this particular open source SDN control plane, and that is what I want to communicate in rest of my talk. This thinking is of course influenced by my collaborators Nick McEwen, Scott Shankar, and colleagues at Open Networking Lab as well as Stanford University. Of course, if I don't communicate this properly or there are faults, they are of course mine. Okay. So, let me start with some observations that I am sure we all agree with. Okay. The first is network operators love SDN. Every time I talk to someone who is a network operator, either in the enterprise setting or in the service provider setting, once they understand SDN, they all like it and they want to adopt it. Okay. Still, we know that the SDN adoption is moving slower than we would like. We all are working very hard on SDN, and still this adoption is slower than we would like. And so, the question is why? Okay. So, I would like you to think for a minute and ask yourself, why is SDN adoption slower than we would like? Okay. I am sure all of you will first come up with the answer that SDN still needs to mature. SDN is a new technology, it is a new paradigm, and so it has to mature more in terms of technology, product, solution, and so on. Some of you may also think that SDN represents a disruptive infrastructure technology, and any disruptive infrastructure technology takes more time before it can be absorbed in a network or in the infrastructure. And I would agree with both of those observations, but I want you to also consider one more thing which is very unique to our industry, and that is the network operators or the end customers, either they are in the enterprise, data center or in service providers, have an increasing dependence on a couple of leading incumbent vendors, and that has a pretty interesting impact or implications on how SDN may get absorbed into real networks. And that is something I will come back to later, but let me first go back to how SDN needs to mature. So, what are the critical components of SDN? If you look at Martin's talk and so on, so you can say there are three components, right. One, at the lowest level there are open flow or SDN optimized forwarding elements. Sometimes people go quite further and say they have to be commodity forwarding devices, but still some open flow SDN optimized forwarding devices. The second critical component is the distributed SDN control plane that has the necessary performance, scale, high availability, northbound API, and so on. And of course, then the third important thing is the use cases or applications that can drive the adoption of SDN. Okay, so those are the three critical components. Now, when you think about the forwarding devices, there is work going on. If you look at how to think about designing SDN forwarding devices, Nick McEwen gave a very good talk at Open Networking Summit in April 2013. Open Networking Foundation is putting a lot of energy in enabling open flow and SDN optimized devices with this chip advisory board and working with Open Compute project and so on. But that is not the focus of my talk today. Okay. So, I am going to focus on the distributed control plane and the compelling use cases. And so, when you think about the SDN control plane, we have been building, you can think of it generation 0, generation 1 controllers that were designed to demonstrate what is possible with SDN. Okay, what type of applications one could build if you are able to separate the control plane from the data plane, and then you have the network abstraction on which you can build application. Okay. But now if you want to make SDN seriously deployable, especially in the service provider networks and so on, we have to build this distributed SDN control plane. And yes, some companies like Martins have built an SDN control plane for data center for network virtualization, but those are kind of proprietary and special purpose. But in general, how to build a distributed SDN control plane still is a big challenge in front of us. So what I am going to argue with in the rest of my talk is, in order to achieve this particular challenge, we have to focus on open source. We have to bring certain communities together and then together be able to build an open source version of this distributed SDN control plane, and that will help us move SDN forward. However, as we do this, what is important is to think about how our industry works and then think about how to build this open source, because otherwise we may not have the necessary impact that we are looking for with this open source distributed SDN control plane. Okay. So, I guess I want to focus on this industry part first. I mean, I think we know that every disruptive technology takes time to mature, and SDN is no exception. We know from this adoption of disruptive technologies, you start with innovators, early adopters, then early majority, then the minority, and then the laggers, right. So, we always have that, but in the case of SDN, we have even bigger challenge, and that is because of how our industry works. And let me give you an example or focus on that aspect of it. Okay. So, what we have is, in simple terms, I am simplifying the world, please remember that. So, what we have is, these are the network operators, most of them, not every network operator is like that, and then these are the leading incumbent vendors. Okay. What has happened over a period of time is the network operators have outsourced more and more of their function to the vendors. Okay. As that has happened, the vendors have been taking on bigger and bigger responsibilities, and today you will notice that the vendors are the ones that actually end up doing architecture, design, and actual sometimes even operation of these network for the service providers, and sometimes for large enterprises as well. So, what that means is that on one hand, we know that the network operators are under profitability pressure. Their capex are growing, their opex are growing, right, their revenue is not growing, and as a result they are under tremendous profitability pressure. What that does is that makes them outsource even more to the vendors. As they outsource more to the vendors, they become more dependent on the vendors, and then vendors have bigger say in how the networks get deployed and operated. And it so happens that these leading incumbent vendors are highly profitable, because now they are operating these large networks, they are in control, they own the market, they can charge high margins for their products. Okay. And unfortunately, these incumbents, it appears, are not likely to bring real SDN to the marketplace anytime soon. Okay. So, are you surprised? Because when you look at all the press and what is going on, almost every vendor is now claiming to be an SDN leader and wanting to build SDN to the marketplace. But here is the history of incumbents with SDN. So, during the phase 1, during the first few years, they essentially ignored SDN. Okay. Then there was a time when they actively tried to criticize SDN, they downplayed SDN, right. And then in last 12 to 18 months, all of these leading incumbents are starting to claim that they are the SDN leaders, they are the SDN champions. However, what they are doing is they are redefining SDN to preserve their legacy. Okay. And let me try to tell you one example of that, what I mean by that. So, what they are saying is, start with these boxes these are these complex proprietary vertically integrated boxes that Martin was talking about, that they are not programmable. It is very difficult to add new functionality in this context. And in this box, you know that this is all the complexity that resides inside this box. Now what they are doing is they are adding some programmable interfaces on top. OpenFlow happens to be one, and they may be adding a proprietary interface as well on top of it. Okay? And then on top of this, they can have something that looks like a controller. They may have some example applications like provisioning and orchestration, and that is their version of SDN, that they are saying we are the champions of SDN. Now the question is, they do also claim advantage of this. The first advantage is it allows the customer to realize SDN without having to buy new boxes. You can do it on existing boxes, and allows the vendor to build SDN on the existing boxes as well. So it seems pretty good, right? So then you ask the question, so what is wrong with this model? Okay? So here is our take on it. What is wrong about it is almost everything. And you say why? So the first thing is it compromises almost all SDN principles and tenets, benefits. So first of all, it keeps the distributed control plane embedded into the boxes. So if you keep the distributed control plane in the boxes, all the state is still distributed in the boxes, it is all vertically integrated, then you are not simplifying the life of the end customer. Moreover, it adds another control plane on top of the distributed control plane. So you have actually added more complexity, and you have added more capex and opex in some sense. And so what that means is the end customer really does not get any help in terms of either reducing capex, reducing opex, or being able to do more interesting things with this kind of SDN. Okay? So that is the big challenge we have, that we have the leading incumbents, we have network operators that are dependent on them, and they do not want to do real SDN, they want to bring incremental SDN. So the question is, how can network operators realize SDN? Because we are all interested in accelerating adoption of SDN with the network operators, but these network operators dependent on these vendors that are not wanting to bring real SDN to the marketplace. So I think that is the bigger challenge we have to think about if we are interested in pushing SDN forward. Okay? So here is one idea that we are trying to encourage or trying to work on. As I said, we want to solve these technological problems with open source, and there is the ONRC project. But what we want to do is, we want to work with network operators and some select vendors. Because if we work with the network operators, our thinking is, or our thesis is, that the network operators will become increasingly comfortable with SDN. They will bring all their problems, and as a result, whatever open source SDN control plane we develop will be useful for the end customers or the end. And we want to work with the vendors, but these are vendors with the star, and these vendors with the star means these are the vendors that are willing to change the status quo. These are the vendors that are truly willing to change how we do networking and try to bring SDN to the marketplace. Okay? So, and if we are successful, then we can break the network operators' dependence on just a couple of incumbents, and they will have more choices, and if they have more choices, they will be able to flourish, and as a result, they will be able to adopt SDN as well. Okay, so here is one way to show this. We want to work with network operators, they may be carriers or large enterprises. We want to work vendors that are willing to challenge the status quo and embrace SDN, and then of course the researchers and innovators. Together we can build a team that has the expertise in SDN, distributed systems, use cases, and open source, and then together we can deliver the open source distributed SDN control plane that has functions, features, and performance that is required, deliver some compelling use cases that the end customers really care about, demonstrations and trial deployments. And if we do this as a community, that is with the end customers, vendors, as well as researchers, then there is a hope that there will be a change and network operators will be able to bring about a change. So, the thing is, each one brings something to the table: use cases and network knowledge, expertise, SDN distributed systems, and then expertise in network distributed system. So, each one of them is bringing something to the table, and in return everybody benefits as well. Okay. So, now that was kind of the strategy or how we want to approach it, what we are doing. Now, I want to briefly spend maybe 5-7 minutes telling you about what is at the core of this open source SDN control plane that we want to develop, and that is, we call it ONRC. It stands for Open Network Operating System. It is the open source distributed network operating system that we have been developing for 18 months or so at Open Networking Lab. So, it started in summer of 2012, and it is focused on 3 things. Okay. It is focused on scale out design, because it is very important that as you are building the network operating system, you should be able to scale it as your network scales, as your control capacity requirements are scaling, you should be able to scale that. It has a fault tolerance, so that because the logically centralized control plane, if any parts of it were to fail, you should be able to tolerate that particular failure, and then we should be able to realize this global network view as a not bound abstraction on which applications can be built. So, those were kind of the 3 critical requirements that we started with. Let me briefly tell you about the high level architecture of this open network operating system. At the lowest level, as you know, these are the forwarding devices, this is the physical infrastructure. On top of that, we have this multi-instance network operating system. So, you can imagine these are multiple servers, each one of them is running an instance of open network operating system. And as your network is growing, you can keep adding more and more servers, and that is how you can grow your SDN control plane, and that is how we achieve the scale out design. Okay. Then these multiple instances need to coordinate among themselves, especially for some of the critical functions, that who is the master of a switch, and so that coordination is achieved using something called distributed registry, and that requires strong consistency, and that is realized using something called Zookeeper. And then this whole network graph is maintained in a distributed state as a distributed state on all of these servers, and that is done using Cassandra in memory DHT. And because we are modeling network as a graph, all these applications that sit on this network graph use graph libraries or graph functions in order to make their life easier, and that is implemented using Titan as the graph library. So, these are kind of the high level architecture. We built it, we did a before I get into that, I want to mention that this is really inspired by Onyx, that was the original distributed SDN control plane that Nicira built. However, afterwards it became more and more data center focused and more virtualization focused, and it is proprietary and closed source, but it is the design is inspired by Onyx. There are of course other network controllers as well. Most of them are still a single instance controller, and some of them are proprietary, and only few that are in the open source. Okay. And so, this was kind of the community doing it, one for the community for open source distributed one. In April 2013, we did a demonstration of ONRC, where we demonstrated that ONRC can be used to control a wide area network. So, what is shown here is a service provider wide area network. It was not a real wide area network, it was in a lab setting, some were physical switches, some were software switches. But what you can see, this is the map of the United States, these are the core switches. So, this is the core network, these are the aggregation switches, these are the edge switches, there are computers hanging off of those edge switches, these are the number of flows that were active, these are the number of active switches, and then these are the multiple instances of open network operating system. So, there were 8 instances of ONRC that were controlling this wide area network, and then we demonstrated how you can do flow setup, you can do scale out design, that as you add more and more networks, you can add more and more ONRC instances, and that is how you can do scale out. We demonstrated that if a link were to fail, how it is reconfigured, all the flows are rerouted, and it all happens transparently in the sense that the ONRC instances figure this out, and so on and so forth. So, but after having gone through this exercise, we realized that the scale out is very important. All of the end customers care about it. High availability is quite important as well, and network graph is a very promising northbound abstraction on which you can build interesting applications. Okay. What we also realized is that achieving performance using open source platforms or tools is very difficult. So, for example, we used Cassandra, we used Titan, we used Zookeeper. So, functionality wise, bringing all these open source components that are out there, it is very easy. You can bring them together, you can demonstrate the functionality. But if you want real performance, then it is very difficult to achieve that performance if you use off the shelf components. So, now we are in the process of figuring out how we can get the performance and functionality together rather than functionality, but without the performance. And as we do that, we are realizing there are many hard systems problems, all the way from how to build this distributed data store with low latency, what are the different consistency models, what are the implications of CAP theorem, and the list goes on. So, the takeaway message is building this distributed SDN control plane is not easy. It requires a lot of systems engineering, systems architecture, and that is what we will have to do as a community if we want to move SDN forward. Okay. So, right now we are working on the core capabilities, different applications, how to build the community and all of that, and these are some of the things we are actively working on how to make ONRC from an experimental network operating system to something that can be used by vendors and service providers and so on. But as we do that, we are using this particular approach because it is not sufficient for us to do the open source by ourselves or with a couple of vendors. It is very important to bring the end customers, that is the network operators, both from the enterprise side as well as service provider side, and we have to come together. And when we do that, and that is how we implement these capabilities, then there are other benefits as well. Not that we get a distributed SDN control plane, that is obviously one benefit, but the bigger benefit is we will be able to change how the industry works in some sense. And the idea is that this dependency that exists, the idea is that can we break the dependency so that the end customers will have more choices and they are not dependent on just couple of vendors. They can build SDN based networks with more choices. And if that were to happen, it will help network operators address hard technology problems. They can be part of solving the problems as opposed to be completely dependent on the vendors. They can help create solutions that meet their requirements rather than again be completely dependent on couple of vendors. And more importantly, they can create SDN expertise within their organization. So, these are the benefits that are pursued by the end customers, and that can lead to acceleration of SDN adoption. If you are this vendor which is not the leading incumbent, but these are the vendors that are willing to challenge the status quo, the benefits are you get to learn how to address the hard problems, work closely with the customers, create solutions that customers would deploy and the customers care about, and as a result you can reduce time to market and grow the market share. So, that is what kind of the value proposition is to vendors that can be part of this particular process as well. Okay. So, that is all I have. We can't take questions.
ありがとうございました。それではここで質疑応答をさせていただきたいということなんですが、ご質問ある方いらっしゃいますでしょうか。 それではただいまマイクをお持ちいたしますので。
Hi, Guru. Nice to meet you. My name is Minho. And I have a simple question from network engineer's point of view. What is the best way, in your opinion, making skill set transition from traditional network engineers to, how can I say, incorporate more software developing skill set? So what is the most efficient way to make this, transition successful in terms of a skill set?
Okay, very good question, and I think that's in some sense it's a difficult question to answer. I mean, for an individual it may be easier to answer, but if you're talking about a whole community of network engineers and how do they make the transition, that's a difficult question to answer. But as an individual, I mean, I think I'm glad that you're thinking along those lines, and the right way to do this is there are SDN tutorials, right? I mean, first of all, you have to have some background in programming or so on, and that is an important skill set to acquire. Once you have that, then there is a lot of material available about how to learn about SDN, and then wherever there are either deployments happening, there are many universities that are doing SDN deployments, or in your work environment try to do the SDN deployment, even if it is in a lab setting or in a small setting, and that is the way I think you can make the transition. But how to do it for all the network engineers as a community, that is a big challenge. I should mention again, because you asked, we have set up something called SDN Academy, and the goal of SDN Academy is exactly this, to help both the development engineers as well as network engineers to make this transition. So how can they learn about SDN, think about networking differently than they have thought before, and that is how they can make the transition. Any other question?
お時間の関係上一問ということで大変申し訳ありませんけれども、どうぞよろしくお願いいたします。どうもありがとうございました。皆様大きな拍手をお願いいたします。Thank you very much.